When the Artemis II crew transmitted this image of a crescent Earth, it became one of the highest definition views ever captured from deep space. The Orion spacecraft has effectively been turned into humanity's highest orbiting studio as it glides over the lunar frontier. To document this flyby, the spacecraft is carrying a massive photography suite, 32 cameras in total, with nearly half of them mounted directly to the external hull and solar arrays. Yet inside the capsule, the crew relies on something surprisingly familiar. Instead of experimental hardware, they are shooting with 10-year-old Nikon D5 DSLRs, chosen because their older electronics have proven to withstand harsh cosmic radiation. They even brought along smartphones. By operating standard digital sensors and familiar devices 230,000 miles away from home, these astronauts are giving the public an entirely new, deeply personal vantage point of the cosmos. But we already know what this terrain looks like. The lunar surface has been meticulously mapped for over a decade by advanced robotic probes. NASA's Lunar Reconnaissance Orbiter, India's Chandrayaan-3, and China's Chang'e 6 have all heavily documented these exact regions. Because of that, astrophysicists are quick to point out that the chance for scientific discovery from an astronaut looking out a window is extremely low, unless a massive meteor happens to strike the moon right as they take a picture. This creates a stark contrast. A robotic probe can gather highly precise, multispectral data for a fraction of the cost. So NASA must justify spending billions of dollars to send humans with handheld cameras into orbit. To understand that justification, we have to look at how robots actually observe the moon. Their primary function is systematic multispectral mapping. They measure raw topographical data across different wavelengths of light. This image shows the standard output of an orbital probe, a flat, grayscale map. This measurement yields immense scientific value, discovering water ice and mineral composition. But for pure data, a fixed robotic satellite will always beat an astronaut. NASA argues, however, that the human eye possesses a unique biological advantage. Our brains are highly sensitive to subtle, real-time shifts in color and texture. While a robot excels at quantitative measurement, a human observer naturally processes the qualitative, environmental context that standard scientific sensors often filter out. You can see this difference clearly when looking at the Orientali Basin, the youngest multi-ring impact crater on the moon, located on its far western edge. Artemis II captured the sheer scale and structural complexity of Orientali in high definition. Even the Apollo missions couldn't view this specific basin in its entirety because their orbital flight paths kept it out of full view. Robotic explorers have already mapped the exact mathematical depth of these rings. But viewing it with the human eye offers a more intuitive, three-dimensional appreciation for the actual thickness of the lunar crust. The academic community treats these new photos as secondary, supplemental data, but the emotional resonance of a human taking the picture carries a weight that raw numbers simply do not. That emotional weight serves a very specific purpose. The primary value of these photographs is political messaging and artistic inspiration, rather than rigorous scientific discovery. This is why NASA encourages astronauts to shoot with standard DSLRs and smartphones like the iPhone 17 Pro Max. It's a deliberate public relations strategy designed for maximum relatability. During the Apollo era, crews shot on heavy Hasselblad cameras, loaded with film that had to be physically brought back to Earth and developed before anyone could see the results. Today, Artemis uses digital sensors to ping data across NASA's deep space network, transmitting high-resolution files near instantaneously to fuel real-time social media feeds. By distributing photos taken with the exact same devices we carry in our pockets, NASA shrinks a 238,000-mile void, turning an abstract celestial body into a tangible place. And NASA desperately needs the public to feel connected to that place. Under intense fiscal scrutiny, the agency has to demonstrate a massive return on its investment to keep its funding. There is also mounting pressure from rival space programs. China, for instance, has set an aggressive target to land its own astronauts on the moon by 2030. At the same time, private aerospace companies are operating with huge budgets and moving significantly faster than government agencies. To secure national prestige and ensure its future, NASA is attempting to recreate the magic of the famous 1968 Earthrise photograph, hoping to trigger the overview effect for an entirely new generation. Robotic probes will continue to secure the precise topographic data required to navigate the lunar surface, but it is the human-captured image, relatable, immediate, and inspiring, that generates the political will and the funding required to actually go there.